Okay, so moving on, we're going to talk a little bit about some properties of molecules. And we just got done talking about ionic bonds, and I wanted to elaborate a little bit more with that with our next PowerPoint slide and our next handout. So if you look at our PowerPoint, it says solubility and dissociation. So these are two properties that molecules can undergo. And if you look at this, it says solubility is the ability of one substance to dissolve into another. So solubility would be like taking sugar and adding it to water, and the sugar dissolves in the water. So it says many substances are dissolved in water or fat throughout our body. Now, whenever we dissolve something, we're going to create a mixture. But the thing that you need to remember is that in solubility, we actually don't change what that molecule is. So the sugar is still sugar, it's just dissolved in the water. In contrast to that, we have another property called dissociation. Dissociation involves ionic compounds. And in a nutshell, what dissociation is going to do is it's going to rip apart that molecule so that the sodium, for example, and the chlorine are separated. So we're going to separate that ionic compound into their cations and their anions. Now, in order to talk about this a little bit more, let's go to Handout 2D, and we'll talk about Handout 2D and separate, no pun intended, solubility with dissociation. So I'm going to get rid of myself here, and we're going to look at this handout. So let's look first at solubility. So it says solubility is the ability of one substance to dissolve into another. So like my example of sugar and water. If I take and add sugar to water, see here's my sugar molecules, here are my water molecules. If I mix water and sugar together, the water and sugar molecules are going to be dispersed kind of evenly throughout our solution. We call this a mixture. So it says soluble substances do not change. They are just mixed together with that water. So we still have sugar and we still have water. They're just mixed together. Now, when we form a mixture, we're going to have two ingredients. We're going to have a solute, which is what is dissolved. In our case, this is sugar. So the solute is sugar, and it's going to dissolve into the solvent, which is the water. So it says the solvent is what the solute dissolves into. So we've got these two things to make a mixture. A solute that we're going to add to a solvent. You know, another example of this, just to give you a quick example, would be if you've got like glue or something from a sticker. Let's say you buy a water bottle and it has a price tag on it and you want to get that price tag off. So what you can do is you can try and peel that price tag off, but it's still got that gooey glue stuck to it. If you take alcohol and you rub alcohol on that price tag, it will dissolve the price tag. So what it is that glue is a solute and the alcohol is a solvent. So the alcohol will dissolve that solute, that glue. And so it's an easy way to get rid of gluey, sticky messes is to add alcohol. So you could add isopropyl alcohol, like rubbing alcohol, or even like hand sanitizer. If you squirt hand sanitizer onto a price tag and just let it sit for a few minutes, you should be able to just scrape that nasty glue right off. what we're creating is solubility, all right? And so that's just a second example. So water and sugar, glue and alcohol are examples of forming a mixture. Now, the other type of property I want to mention is dissociation. And dissociation is important for us because our body's going to be doing this to create ions. And so it says dissociation or separation, a substance is pulled apart by another. So our example here would be salt and water. So this isn't sugar, this is salt. So notice I've got my water molecules. And remember I told you in that last video that water is polar. Water is going to have a positive side and a negative side. So what happens when you add salt to water is you don't get a mixture like you do with sugar. You get a dissociation. So the salt is made up of a positive sodium and a negative chlorine. Water has a negative side on its oxygen and a positive side on its hydrogen. So when we mix these charged molecules together, what's going to happen is that sodium part of the salt is positive. The negative oxygen areas of the water are going to be attracted and surround that positive sodium. The opposite's going to occur with the chlorine. The chlorine is negative, so the positive hydrogens of the water are going to surround it, and we're going to pull the sodium and chlorine apart. We're going to dissociate the salt into ions. So now we have a separate sodium ion and a separate chlorine ion. Now, what makes this important is our body needs these ions. And we're going to use these ions to run our body. So dissociation is a really crucial part of what our body can do to form these ions. So anytime you eat a salt or anytime you ingest an ionic compound that's made of ionic bonds, we can dissociate these molecules, pull them apart, and then we'll have ions that our body can then use. All right, so that kind of wraps up Handout 2D. Moving on.